In this lesson, we'll be talking about DHCP, the Dynamic Host Configuration Protocol. DHCP is a really important protocol as well as an important program or service. The reason it's important is it makes it really easy to add systems to a network. If you have a DHCP server running on your network and it's properly configured, all somebody has to do is plug their system into your network and they will automatically obtain an IP address, subnet mask, and router information, as well as several other different types of information that you may choose to configure to get your network clients configured with. There's a downside to this, of course. Somebody can plug into your network and automatically be on your network. But particularly with large enterprises, it's much easier to use DHCP to get your systems up and running on your network, so you're not going around and configuring by hand everybody's system who's on the network. Not only is that time and resource consuming and really expensive from that perspective, but it also makes it difficult for systems like laptops, for example, to be removed from desks and brought to other locations in the building. So DHCP is really helpful, not only to get you up and running faster on a network, but also it provides the ability for your users to be more mobile, particularly if they've got systems that are capable of being mobile. So let's talk a little bit more about what DHCP is. And I've got a DHCP server running on this Linux system. I can show you the DHCP configuration file, and we'll take a look at the various things that we can configure here. So I can configure a domain name. So when you just type in one portion of the host name, you're configuring the search order, basically. So if I were to just type foo in this case, your system, since I've configured a domain name, would assume that you really meant foo.example.org. I can also configure domain name servers, so you don't have to go configuring the DNS servers yourself. I'm just going to push them to you, and I can keep traffic for DNS within my network by ensuring that you stay with my DNS servers rather than using more global ones. The default lease time here is 600, and the default lease time has to do with the amount of time you are allowed to keep an IP address before you have to go back to the server and say, hey, I need that IP address again, and it will either allow you to keep that IP address or it may give you a whole different IP address. So there are some trade-offs here. A shorter lease time means you're constantly talking to the DHCP server, while a longer lease time means that your DHCP server, if you've got a lot of systems that come and go, your DHCP server is going to hold that IP address and not let anybody else have it, or it's not going to place it back into the available pool until that lease time has expired. So if you've got a lot of systems that come and go, you run the risk of running out of your pool of IP addresses because your DHCP server is just holding them all for systems that came and may not come again for quite a period of time. Here's some information about how we're going to log what's going on with our server. And they're just basic frameworks for how you would define a subnet that gets served up using this DHCP server. So here's a very basic subnet, just 10.152.187.0 with a net mask of 255.255.255.0. We're not providing any other options than that since we gave the DNS up above. And maybe we don't want them to have a default gateway or a router so that they can't get off the network. Or you can add any number of other options yourself. This is just a basic framework to get you started. Here's another basic subnet declaration. I've given a subnet here. I'm saying that my range of IP addresses, in other words, my IP address pool, is from .10 to .20. I've given routers here, so I've got 2 routers or 2 default gateways, and of course I gave the DNS as a global configuration up above. We can also do things like providing broadcast addresses if you want to do that sort of thing, although your system will usually assume based on the subnet mask what the broadcast address is, and it would be the correct one. We can say a particular host has special configuration, and so we can set up hosts based on their hardware address or their MAC address. And if you specify the MAC address, you can then say, here are some other configurations. And in this case, what we've set up is a TFTP boot server, and we're providing this system the boot server name as well as the file name that it's going to use to boot off from. So there's a whole lot of other configuration parameters that you can use on DHCP. Again, this is Linux. The DHCP server will have the same sort of configuration parameters on a Windows system, and of course the way you would manage that would be through a graphical user interface that Microsoft would provide. So that's the configuration side. Let's take a look at how it's going to look on the network. So here's a Wireshark capture. I've got a DHCP request and a DHCP acknowledgement. In this case, the DHCP request, even though we call it DHCP now, DHCP came from an older protocol called the Bootstrap protocol. So when you're looking to filter in Wireshark, you would use BootP, which is what I typed up here, and it's now gone from the filter box. But you can see down here is the Bootstrap protocol. And let's zoom in a little bit. So the request type or the message type is boot request. There's a transaction ID. I've got some flags. Client address is blank. The client MAC address is my MAC address or my physical hardware address. And the option is a DHCP request. And there's a parameter request list where I'm asking for subnet mask, router, domain name server, domain name, domain search, and a number of other things. Now here you can see I've actually requested an IP address. What that means is I previously had this IP address, and for ease of use, I would like to have it again. And the DHCP server, if it knows about this and if that IP address is available, if it doesn't know about it, then it's going to give that IP address. So that's the request. Now let's look at the acknowledgement. This would be from the DHCP server back to me. And you can see that the server IP address is 192.168.1.1. My IP address is 1.26. I've got the MAC address again, which is the physical address of my system. DHCP server is going to be 192.168.1.1. It's giving me a lease time of a day and a renewal time value of 12 hours. So even though I've got the lease for a day, after 12 hours, I need to be asking for the lease again. It's got my subnet mask, my broadcast address, the router address, which is the gateway, DNS server address, a domain name, and up above it gave me my IP address back. So these are what the DHCP messages look like. Again, I pulled them right off the wire, and Wireshark has actually pulled this apart into its individual pieces and is presenting it to us in a way that we can read. This is not actually what the packet looks like. What the packet looks like is what's down at the very bottom. It's all in hex, and you may see some ASCII characters there from time to time, but Wireshark does a really good job of presenting the information in a way that's easy to read and easy to understand, which again is another good reason for using Wireshark. So that's some information about DHCP and how it works and how you would configure it and what it looks like on the wire.